Hi friends, welcome to Water Treatment Basics. My name is Pranav and in this tutorial I will explain about water hardness. So let's get started. Topics I covered in this tutorial is what is hardness of water, reaction of soap with water, hard water versus soft water comparison, types of water hardness and removal methods, determination of hardness and hardness units and conversion tables. So first of all, what is hardness of water? As per the chemistry, the amount of calcium and magnesium ions present in water is called water hardness. But I think this definition is unclear to many people who don't know about water chemistry, so let me explain in a very simple way. Simply we can say that leather producing capacity of water with soap is also called water hardness because hard water contains more calcium and magnesium ions and produces less leather with soap, while the soft water contains less calcium and magnesium ions and produces more leather with soap. To understand clearly, we understand the reaction of soap with water, and in this section you will also find the reason why hard water produces less leather with soap. So here you can see in the reaction, hard water react with soap and precipitate as a scum. So here I represent calcium and magnesium ions as a hard water and RCOONA as a soap, and when it will react with each other, that they produces RCOOCA and RCOOMG, which is salt precipitation or scum. So basically soap contains long chain fatty acids of sodium salts, and when soap react with water, calcium and magnesium ions present in water is converted to corresponding calcium and magnesium salts, and it is precipitated as a scum, and this scum is sticks on the surface to be cleaned so that cleaning capacity of soap is reduced. So hard water is react with soap and becomes as a salts precipitation, and so that it will not produces good leather forming with water. So this is the reason. So now we compare the hard water versus soft water. What is the difference between them? Hard water contains more calcium and magnesium ions, and soft water contains less calcium and magnesium ions, produces less leather with soap and produces more leather with soap. When total hardness value is greater than 60 ppm, then water is considered hard, and total hardness value is less than 60 ppm as CaCO3, then water is considered soft. ppm as CaCO3 means parts per million as calcium carbonate. So water hardness is divided in two parts: carbonate hardness or temporary hardness and non-carbonate hardness or permanent hardness. So now first we understand the carbonate hardness or temporary hardness. Hardness present in water is due to the carbonate and bicarbonate ions is called carbonate or temporary hardness, and it is called temporary hardness because it is removed when we boil the water. And the example of temporary hardness is calcium carbonate, magnesium carbonate, calcium bicarbonate and magnesium bicarbonate. Secondly, we understand the non-carbonate hardness or permanent hardness. And hardness present in water is due to the chloride and sulfate ions is called non-carbonate or permanent hardness of water, and it is called permanent hardness because it is not removed when we boil the water. To remove it by softening or demineralization process. And the example of permanent hardness is calcium chloride, magnesium chloride, calcium sulfate and magnesium sulfate ions. So now we go to this analysis part. Then as per the point of view of analysis, water hardness analysis is divided in three parts: calcium hardness, magnesium hardness and total hardness. And please remember that total hardness is the sum of calcium and magnesium hardness. So now first we determine the total hardness value of water. To determine it, fill the burette with EDTA solution and take the sample in a flask and add ammonia buffer solution to the sample to maintain the pH around 10, and then add EBT indicator. EBT means ethiochrome black tea and EDTA means ethylene diamine tetraacetic acid. So now titrate the sample against EDTA solution, and at the end point color is changed from wine red to blue. And to calculate the total hardness as ppm as CaCO3, multiply the burette reading, which is the volume of EDTA consumed in analysis, and normality of EDTA, and 50, which is the equivalent weight of calcium carbonate, and into 1000, and 1000 is the factor to convert hardness value in ppm as calcium carbonate, and divided by the sample volume, which is in ml. And now we determine the calcium hardness. To determine the calcium hardness, follow the same procedure. Fill the burette with EDTA solution, take sample in a flask and add sodium hydroxide solution instead of ammonia buffer solution, which is we used in the total hardness analysis, and here add the burette indicator. Now and titrate the sample against EDTA solution, and here the color change is from pink to purple. To calculate the calcium hardness value, we follow the same formula which is used in total hardness analysis. And now we determine the magnesium hardness. So to determine the magnesium hardness, there is no need to do any titration analysis. Simply we can calculate it, because as I said earlier, total hardness is a sum of calcium and magnesium hardness. So we have the two values, total hardness and calcium hardness. So to find out the magnesium hardness value, we subtract calcium hardness value from the total hardness value. So now we understand the hardness classification as per the hardness value. So here you can see in the table we have 5 different units. First is total hardness ppm as calcium carbonate, German degrees, Clark degrees, French degrees, grains per gallon, and then finally as per the value we decide the type of water. If hardness value is less than 60 ppm as calcium carbonate, then water is considered soft. If between 61 to 120, then water is moderately hard, and if between 121 to 180, then water is considered hard, and above 180 ppm as CaCO3 hardness value, water is considered very hard. And now how we can convert the water hardness units. To convert it from ppm as CaCO3, multiply by the factor here I mentioned in this table. For example, if you want to convert milligram per liter as CaCO3 to German degrees, then you have to multiply the ppm as CaCO3 or milligram per liter as CaCO3 value to 0.056. So that's it guys for this video. If you like my tutorial, then give a like, and if you have any question, please ask me in the comment section, and thanks for watching.